Sir, recording is started.
Okay.
Vamshi, can I share my screen for us for 5 minutes?
Sir, your co-host, sir, you have the option.
Oh, okay, okay. Can you see the screen? My screen where?
Yeah, yes, sir, it's visible.
Yeah, it's going on quite good. Yeah, the quiz is over now. We can start with the session. I'll stop sharing. Yeah,
Okay, Girish.
yeah.
Good evening, everyone. And this is the third episode of this series. And um, thanks for attending in a holiday. I think this is a Saturday also and a holiday. But yes, the enthusiastic people take this opportunity to use this kind of extra learning or extra knowledge. Kudos to you, all of you. And let me start the students' session. This is going to be very interesting. And today we'll discuss how a computer or, yes, the programming language is born and how it evolves. Let me share my screen. I would like to thank CEDA Bangalore for giving this opportunity and hosting me, and CEDA Global and all the enthusiastic volunteers like Girish, Vamsi, Sajal, who is also taking their time to attend and arrange this one. As you know, we are discussing the electronic design automation, and my name is Aloke, and I've been working in this field for quite a long time. So far, we have discussed so many things, the introductions and all those ideas. And in the last session, I showed how command line parsing happens. And after that, we did some hands-on coding last session 2 weeks back. And today's topic is like we have completed command line parsing, and now today's topic is language parsing. This is the heart of the compiler. This is the heart of compiler. Here, the compiler reads the language reads the language means that programming language. So basically, uh, let me share another thing. Okay, here the compiler reads the language. That is very important, and today I'm going to show you how it is how it does that thing, the reading the language. So very important, carefully look at this. I don't know how it is kind of projecting in your screen, but let me zoom it little bit. See, this is the standard where IEEE comes into play. The Verilog is a language that is developed, and somebody developed, some laboratory developed. After that, they wanted to make a standard, means everywhere in the world follows the same rule of the language. Then what they do, they comes to a organization like IEEE, because this is related to electronics. So IEEE is the first choice, and IEEE has a standard division, IEEE standards. So there, people voluntarily join and creates a group, which is a standard group, and this standard is given a number 1364. 1364 is the Verilog. It's a standard for Verilog, and this is how this, and after that they sit, discuss, and create this document. Very important. So this is the document where the language is kind of defined. This is the Bible for us who works on, who writes, or anybody who wants to write a programming language. So this is the Bible for us. So this is the standard, and it is written all the rules, every nook and corner, every corner cases, every small minute details are listed here. And if there is any ambiguity, this is the document which has to be referred to solve these things. So I'll show you the full document, how it looks like. This is the document, and after today's session, I'll send it to you in the WhatsApp group. This is how much, 791 page long document, and here it is written. I hope everybody is able to see this thing. IEEE Standard Verilog Hardware Description Language, led by Computer Society, and published in so and so 2001. And there is a previous version. This is a revision of 1995. There is another document which is called Verilog 95, and it is the revision of that. So this is how a language is born. A programming language is born is like this. And IEEE standards acts a very important role to give birth to a language. And see, this is an interesting section. Everything is interesting, but one thing I would like to show you to motivate actually. See, this is how the committee was formed. Maksudul Mannan is the chair. Kausumi Himaguchi from Japan is like the vice chair, and the members are listed like this. And if you are serious, if you devote your whole career to this kind of activity, it is always possible that your name is listed here. You could be the part of the standards group, and you could write the future programming languages. And in this IEEE standard documents, your name can come. That is no wonder. That is no wonder that your name will come here, and you can proudly say that I was part of this standard, and this language I contributed to give birth to this language. And there are many other following members names. So when I send the document, you will see it. Only one thing to notice, very few Indians are there in this list, so which we have to kind of change. We have to take some kind of oath or something. Maybe we should think about to become part of it, not a passive part, actively define the language and take part. And of course, Verilog will be modified 2001, 2005, 2012, till 12 it has come. Maybe it will be another revisions will come, and you can take part on Verilog itself only, and your name can come here. This is a very like forward looking or motivating thing. Let's get back to our topic. So so this is the language, okay, and in this language there are sections. One is what? Lexical conventions. Okay, and there are annexure, formal syntax definition. See, very unfamiliar to you, isn't it? Very few of you have seen this kind of description about a language, but this is very common for us who has developed compilers for one or two languages. So this is our Bible, and here the rules are defined. What is allowed, what is not allowed, what is allowed, this is the grammar portion. I'll talk this in the next session, means 2 weeks after that. Today I'll not cover this grammar, but I'll cover this scanner today. But nevertheless, this is the rules we have to follow. This forms this the rules of the language, what is allowed, what is permitted, what is not permitted. Again, going back to the original document, see, this is the content overview, lexical conventions. Mostly it comes in the second chapter of every standard, like this, lexical tokens, what is white spaces. I'd like to go to this page number 6. Let me go there, and I want to explain little bit more here. So how to start? Writing a compiler. Okay, what is the page number here? This is 8. So this is 7, and this is the lexical which I captured in the presentation. So here it is written, what is white space? Means everything has to be defined in the standard, and you have to follow that. What is a white space? There is a definition of white space. White space shall contain the characters for spaces, tabs, blah blah, whatever. The description should be there. What is the description? I'm not going into deep into it, but my point is, see, everything is defined here. How a comment look like in Java, in C, C++, Verilog, every language has a comment, like how to write a comment, which will not be processed by compiler, but it is very helpful for the others to see, describe about the code, what is there, what is the algorithm, why this is done like this, what this function does. We write as a comment. So how that comment should be, it is also defined here. Operators, what are the operators allowed? It is defined here. Okay. And also, what is a number? What kind of how you write a number for Verilog? What is a string? How you should write it? Everything, every detail is defined in this standard document. So this is the first section. We will look for it because this is the lexical scanner. We write code for this lexical conventions. We'll design the scanner. This is called scanner part, which I will cover today. And there will be other, which is grammar, that I'll share later. Okay, lexical tokens. And what I was saying, the annexure, there will always be an annexure where the grammar is defined. See, formal syntax definition, page number 711. So if I go 711, this is the lex. So here the grammar, the syntax, module name, open bracket, then port name, comma, close bracket, semicolon, all this, that is called grammar. Rule of the language, that is defined here. But see, the definition is very peculiar, very different. So I'll explain it in the next session. But this is the two sections. Actually, we have to refer. If you want to write a complete compiler, you have to read all these 800 pages. But these two sections are very important to start with. Start your this thing. This defines the grammar of language, and that page section 2, that is the words. And there is other things also. Keyword, list of keywords. Every language has keywords. What is that? I'll also describe. With that thing, I'll go to the my presentation again, and I'll start. So if you have any questions, just let me know. So these are the things I have captured in this slide. One is to highlight this is a standard. There is a Bible for this language, and in these two pages or sections are most important for designing a compiler. So coming back to our business, creating lexical scanner. So that lexical scanner, the word itself is kind of, you might not have heard before. I'll explain it. So what is a language? Language is a stream of tokens. Means stream, like character by character. What is a language? What is the English language? Bengali, Hindi. It's a character, a series of character. And one character in computer is a byte. English language is a byte. So what we write, any language, we write a stream of characters, and that's how that is true for computer also. The language is a stream of tokens. So what is a token? I'll explain that thing. A token is a stream of characters. So you can think of like a language is a stream of words, and each word is a stream of character, like that. But there is a difference, since it is a kind of computer. So you can do many kind of manipulations. So in normal language, English language, a word means the character, the set of character between two spaces, right? Isn't it? But here uh, it could be different also. We'll talk about this. A delimiter separates the token. The space, what is normal for us, for English language or any language, is called delimiter in terms of computers. This delimiter by default is space for computer also, but you can change it to any character. It can be a semicolon, it can be another character, maybe A. Then the stream of character between two A becomes a word for that, and that may contain space also, because space is nothing but a character. So for computers, delimiter, you can change it, and you can do interesting things, but we'll not get into that. That is the subject of computer science, guys. We are electronics guys, will not go deep into computer science. So here we will take delimiter as a space. So between space, two space, one word will come. That is called token here. In English word or any language, that is called the word. Here, token is like a word. Space is the delimiter generally, but generally means that's what I have just explained. Tokens are of different types. For the computer language or programming languages, tokens, those words could be keywords, because the module is a keyword. But other words, the name of the module, that is also a word, that is also valid, but that is not a keyword. So there is a differentiation. Those who are not keywords but still words are called identifiers in the compiler language. So we call them identifiers. Basically, they are the names, and there could be operators, and there could be value of the variables, like something a equals to 5, a equals to some string, anything could be there. So all those things are called tokens. So this is a typically Verilog language. Here, um, this is a token, module is a token. EOART is the name of the module, that is also a token. This output is a keyword, that is also token. This double slash, notice this very carefully. This is doesn't look like a word, but this is a token for Verilog, because this signifies the start of a one line command. So this is also a token. This has a meaning, significance, like that. This is a value, this is a number, 9600 baud rate. This is also a token, this is a number. These are all the variable names. And sorry, not the variable names. This semicolon is a token, this close bracket is token, this square bracket is a token, this colon is a token, because it has a specific meaning. It is actually like a word. We treat them, we take action based on those things. So everything, every meaningful single character or set of characters is a token for computer language. And this is the function of a scanner, lexical scanner. So it scans, the whole this text, whole text. It scans line by line each character, and it compares with something. I'll come back to that later. So this scanner always scans the whole language, and the moment it sees it has got reg, then it does something through computer programming, that it understands it's a keyword. How? I will show you today. And what is the name of the keyword? Keyword is okay, that we can understand, but there should be more, something more, so that it can take actions. So after that, there is another set of programming which converts it to something called enumerated value, k underscore reg, enum. In C++, there is a enum. So this is how it understand a register is used, reg keyword is used here, and based on that it can take some decisions or actions. So this is how the lexical scanner works, and this is why it is needed, because reading means we have to understand word by word. In English also, in any language, you have to understand word by word, then only you will be able to understand the full story, or whatever is spoken, whatever is written. You have to understand, you have to scan through the language. So that's how the job of a scanner. Any questions, any point of time, just stop me and ask.
Aloke,
Yeah,
I just had a question regarding
yeah.
the sequence. Is it correct to say that in a Verilog program, all the text except variable are tokens?
Variables are also tokens.
Variables are not also tokens. Okay.
Yeah. Okay, moving on to the next slide. Writing the lex file. So this all concept is clear. Now we have to start writing the actual compiler. How do I do that? Writing the lex file. There is something called lexical scanner file, lex file, and there is a specific way to write that file. And this is called a new way of collecting tokens. So this is how, this is another language. This is very interesting. Another language is used to create a language compiler, language reader. So we'll show it. Today we'll do also hands-on. I'll show it. So this is called Lex file generation, a new way of collecting tokens based on regular expression. See, this regular expression also is a big topic, and that can be, we can spend like 2 hours, 3 hours on that only. So I'll not get into that today, but it is very well known concept in computer science. You can get any kind of material from Google. So this is important. This is heavily used in compiler design. Basically, this Lex file scanner, and this new file with regular expression, and also we have to take help of C codes to write a Lex file. There are 3 sections to write, and after you create this Lex file, you have to compile it through a tool which is called Flex. And this, after compilation, this file will be converted to a C file. It will not create any executable or anything like that. It will create a C file. Why? Because the same scanner can be earlier days, like 30-40 years ago, this scanner was written by C programs. The programmers using C language, plain C language, they used to create these scanners. But later the language became so complicated that it was difficult to write a scanner using only C file. Then they invented this Lex thing, and now everybody writes a Lex file and compiles it to create a C file, and then again uses a C compiler to make the executable. And after compilation, it creates a long C file, and that's where people saves a lot of time, and also it is accurate. Uses old C syntaxes and functions, and this is the half of the parser. So as I told, there is a grammar portion. So this is the first half of a compiler, which is called lexical scanner, and this is the file. This Lex file looks like this. See, the 3 sections are this: percentage, open curly brace. Within this is a section. Then here to double percentage, there is a section. After that, the double percentage and double percentage, there are something is written. I'll explain that. And there is another this thing. I'll show that. So here in this first section, you can write C code, mainly the headers, the include headers and external declarations, and all those things has to be written in this section. Percentage open curly brace, then percentage close curly brace. And this, I'll not explain it. This is kind of definition of tokens or token names, I would say. This is complicated. I'll not get into that. And this is the C code, and here this is the regular expressions. See, A to Z, small characters, then uppercase characters, underscored, then something, then star. I'll explain it little bit what it means. Whatever may be, inside this curly braces, you write C++ code. So this is how it is created. Now let me define a little bit. So what does that mean? This is the token definition of token. How? For example, look at this. What it says, this is a regular expression, typical regular expression. What it says is the square brackets means the token, if a token, or maybe for simplicity, if a word starts with lowercase or uppercase, A to Z means anything in between small a to small z, and anything between capital A to capital Z, or underscore. This means the first character should be this. After that, from second character, it could be A to Z, again capital A to Z, and 0 to 9 numbers are possible, and dollar is also possible, underscore is also possible. Then star means second character could be one of these, zero or more of this. Means in simple language, any word which starts with with a character and can have zero or more character, dollar, underscore, or nothing. This star means this one or more occurrence, and this kind of thing is matched with the language. Suppose this is the language, right? According to that rule, whether this is okay, that is checked between the like when the Lex generates the C program, that program checks this according to that rule, whether it is fitting, it is okay, this is okay, this is okay, anything, everything is okay, like that. That checks happens for every scanning. Okay, so that is the job of a scanner. So this is called the regular expression, and based on that it takes some C code definition, right? So here it is, what it is defining, something something, if it matches, then return based number, means then call it a number. This is how your program, your compiler will understand whether you have written a keyword, a name, a number, a operator, or something. If you see the later, this portion, the last portion of this file, see dash greater than, is a deref, means dereference, means a pointer, right? If you remember, a pointer is written like this in C languages. In Verilog also, this is kind of a same thing. Plus equals to means incremental operator. So INC, I am returning INC. So like this thing, see, only semicolon is also tokenized, told you, right? So if it says only single semicolon, it will return semicolon. So returning is important because based on this enum, this will create a set of enum, enumerated value in C. Based on this thing, a lot of checks happens inside the C code, and then based on that only you can take actions. So for each token, I am returning a name. This name is nothing but a enumerated value, enum, C enum. So this is the technique we follow. And after this happens between this double percentage and double percentage. All the lexical rules, the regular expressions are written in between this. So this is the most important section of a lex file. And here after this you can write another functions. Generally there is something, some conventions, will take it later. But see here, whenever the matching happens, you are continuously scanning the character that is being read from your Verilog file, and you're continuously trying to matching with all of them. Maybe that word matches to this, then what you will return? You will return identifier. If it doesn't match or something, this matches this, you will return an identifier. If it matches like 0 to 9, then 0 to 9, 0 or more occurrence, this is a decimal number. See how I am creating the regular expression, scanning, matching, and returning a enum from my program. This is works in tandem. Lex file, regular expression, and C code together. So this is the beauty of this writing this lexical scanner. Okay, I'll not spend much more time here, but everything is a token, like square bracket or curly bracket. All those things are also token, and also like name like module, UART, all are tokens. And based on the rules, we give a name to them, whether it is a keyword, whether it is a name, it is an operator, it's a semicolon or something like that. Good. Now another thing I have to introduce here for keywords. See, tokens. Okay, we have understood the tokens and we have classified them also based on the matching of the regular expressions. We have named it. Each tokens we have named it. Fine, that's fine. Very good. So after that thing, what we have to understand, there is a few words which are keywords, like module. Module means, has a special meaning. So if you go back to the previous example, if you go back to this example, okay, see, module and UART both are identifiers, both are words, but this is special, right? Module is a keyword, UART is not a keyword. You can make it ABCD, anything. The name of the module could be anything. But module is a special word. Input is a special word. Similarly, if you see this baud rate equals to, you need to give a value, right? You cannot give it like baud rate equals to input, baud rate equals to module. That is not permitted, because that is a keyword. Keyword has a special place to use, special rules to use. So you cannot use it anywhere. But see, output, sorry, this txbz, it can be any name. There is no rule like that. So for that thing, what I'm trying to say is, for you have to understand, while scanning itself, you have to identify the keywords and their usage, whether they are properly used or not. Any language has a set of keywords. Keywords are special identifiers. They are still identifiers, but the special kind of identifiers. It must not be used as names or values like that. Module name cannot be module. Input signal name cannot be module. Like you cannot use module, that word, as a signal of or port list of a module. That will create a confusion. A function is needed to check any word. Means from the scanner, when you are getting the tokens, that tokens you have to check for keywords. How it is done in computer science, there is something called hash table and hash functions. Hash is a data structure, special, very special data structure, where we try to find um, mm, like whether something is used multiple times or one time, like that. So hashing is a very important topic in computer science. Again, we'll not get into that. That is hash function and hashing, hash table. It's a big topic. We'll not get into that because we are electronics engineers. So but still, it is good to know that hash function is used for identifying these keywords. gperf, so hash functions means you can write it by hand, but there is like lexical scanner can be written by C, but they are using a new tool called flex. Here also gperf can create that function easily. We will be using another program called gperf, and we'll be using that program to create that checking. How it looks like? It looks like lex only. Again, that percentage curly, open curly braces, this in that. And there is a, I think it is little bit easier. You can figure out. So this is the C code portion. But here in the percentage, between percentage, you write what? You list all the keywords and value, key value pair, and if you remember, if you read about hash table also stores key value pair, like that. And it is written like that, each keyword and what you will return from that hash function. This is how it looks like. This is the hash function name that you will be using, that you can write it here. And here the tokens, right? Here another function is written, we check, okay, rdl keyword, check identifier. Okay, check identifier is a hash function which will tell you, based on this list, what token you have given, you have got, whether that is a keyword or not. If it is, if rc equals to 0 means it is not a keyword, then it will become identifier, you will return the identifier enum. But if it matches any of these key value pair, then from this struct rdl keyword you will return this token type. Token type is the second thing. So you will know what kind of token you have got. Maybe will not be relate right now because I'll not be talking about the grammar. When I describe the grammar, the circle will be complete. You will be able to relate why we need to return this token type. You may be thinking, right, okay, we know this thing, right? Well, but why should we create the structure and return the k underscore something something? So that will be clear that time. But this is how with the scanner we can also check for the keywords. So now I'll stop, and if
Hello?
you hello.
Yeah, just a question. Just can you just go one slide before? Here, the module is also a keyword, right?
Module is keyword, right?
So, but I don't see that in this list.
Okay. So I, since to accommodate in this slide, I have deleted many
Okay.
things.
Yeah.
Just keep something. So I'll pause for a minute. You guys can take a break or something if you want to ask questions. and you can note down. I can take on, and let me see the time. It is almost 7. Okay, so we have a good amount of time for coding and also discussion. I'll be back in 1 minute. Okay, I'm back. So, what we have discussed so far is there is a Bible for each language, programming language. For computer science, most probably it will be from Acerella or NC, those kind of organization. For electronics related, it will be definitely IEEE, and some computer science languages also can be, the standards can be created by IEEE Computer Science Society. When we write a compiler, that is our Bible, and we generally not we have to look at that. The two section is very important. One is the lexical conventions, the tokens, definition of tokens, then the grammar, and the list of keywords. This three section is very important. According to that, we have to create the lexical scanner, the zipper file, and YAC file later. That will come in the next next session actually. So now I'll open my virtual box for coding. Meanwhile, I'll share my screen. I think because this meeting is running, that's why this is taking some time, but that's okay. I think it'll come. Yeah, it has come, and so where we were at working, um, that is a project directory, and Toolsmith. Uh, okay, so so I will go to another directory where I have created another language, which is called system RDL. Mm, RDL Parser front end. So vi tool dot cpp. So let's create where we just this thing stopped here, and how this is done. pi rdl main.cpp. Look at this. I hope everyone is able to see this thing. So this is my main function here. This is a peculiar variable you don't know, but don't worry about it. These are coming from some other this thing, and we will call it from the main function. You have to call the lexical compiler. Lexical compiler. So we have not created by parts, so I'll not be able to call this thing, but what I can call is now we will create our tool.l. So I will just copy paste this thing. I'll just look at it. Percentage open curly bracket, and then This is the standard way of writing. It is written. I have shared Lex and Yak book. It is written there. Why we do it? There is an explanation, but no need to worry about it. This skeleton, the structure of this program should be there. This kind of things should be created from a template or from some other code, and here is the portion you have to kind of add to it. Here I have only added, because I'm doing right now, so I have added only this one regular expression to catch the identifier. And when we towards the end, this will be your base file. Similarly, I'll show you only one grammar also, how to write a few lines, like maybe you will be able to parse only one line of Verilog code. And your project, what we are expecting at the end, you have to add more. How much? That depends on your time, interest, and all these things. But we expect at least add few more grammar, few more regular expression to catch, like here only identifier. Now add something to catch the numbers, so that your compiler can understand, yes, this is a basically number you have got. So that is the idea of this whole program. We can understand that it is not possible to write the whole compiler, but add to it, make it these files as a base. And see, this is a proper compiler. This is not for Verilog. This is for parser. RDL stands for Register Description Language. So I have written this Lex file for the whole language. And of course, it has another kind of standard document by following that. So this will be your job. At least add one more lexical scanner to it, like that. Hex number. See, by this rule, I have captured what is a hex number should be. Hex number generally which starts with 0x, then 0 to 9 could be there, or A to F could be there, or capital A to F could be there. Plus means one or more occurrence. So this kind of things has to be done by you during the project towards the end. So I have designed this thing, and hopefully it will compile. Okay. Let me open this thing in background so that I can check what is wrong, what is not wrong. And there is another thing which is basically make file. I'll not get into that today, but I want the okay, this is the function flex minus. Okay, so it is compiled. Now it is compiled and it has created this lexer.c. So let me show you rm. See, lexer.c was not there. If I run this compiler, the flex is the tool to create the scanner. Then this lexer.c is created. If I open this lecture.c, let me see how it looks like. See how many lines? 1743 lines has been created out of this. Okay. Uh, Out of this, how many? 15 lines of code. See, this 15 lines of code has generated 1743. That means if you have to write this scanner, if you don't take the help of Flex program, Flex tool, then manually you have to create these many lines of C code. See, it is only C code. It is all C code. Okay. So that is the amount of effort this tool is saving. Okay. So let me see YYLEX whether this function is available. Yes, external int void YYLEX. Okay. So now I will create another file which is vi tool dot gperf. This extensions doesn't matter. So you can give any extension name. This is just for our understanding. There is nothing, no significance for that. What I will write it in this, if I open RDL keywords.gperf, again the same syntax. So now I'll be creating a structure. This is purely a C structure where I will capture the keyword and key value pair. Okay. So here I will write module, then key underscore underscore module. So this K module can be anything at your choice. This is the keyword. The scanner, the file, in the file you will encounter this. You cannot change this name, this keyword, but this is a name of the token that you can choose anything. There is nothing it has to be module, no, nothing like that. So you can choose it anything. So I have created only one, or maybe it is kind of input, output. I'm creating 4 keywords, which is very common. So this is the thing, and this last function is needed. I'll just copy paste here. Because this is the actual check. It happens here. This is the function which checks this thing, and this is the code you need basically. So this return identifier, this is also a kind of enum, and RC token type. This is the structure we have created, and based on this thing it will create like this. So let me compile this gperf also. I have to check the make file. How did I do that? So this is the command. I have to change the name of the file, which is basically in this case tools.gp. See how much code it has created. It will create in the std out, means this window. So what we have to do, we have to capture this thing, tools dot tools gp dot c. It will also create a c file, and if I open this c file, it looks, see how it is created. This is the kind of hash table which I was talking about, and it has this function also, and it has code for that. See how it is created, and like that. And this is the final function which will decide how to do this identifier checking. So I think I should stop now. We are almost 7:23. So in next day, I will check. I'll also connect these two, gperf, lex, and I'll talk about yak also, grammar portion. Okay, together we will connect this from this main dot from here. We'll call the lex file, yak file, gper file. All these things will be calling from here, and I'll show that thing next in next series. That's all from my side. Girish, you can take over.
Yeah, thanks, Alok. Just wanted to ask you, if it is possible to give a series, the list of the commands what you just showed us now, because it's difficult to remember everything.
Correct. Correct.
If you have any document or any list of this one, if you can type, and also the sample files, whatever you have created now, if you can share, then that will be a starting point for the students and participants, and they can play with it and take it
Correct.
together.
Yes.
And
I'll
any
send
perhaps, yeah, you have given these tokens that whatever you defined, they can also add more number of them and try out.
Correct. Correct. And in addition to that, I'll send a presentation on Lex and Yak.
Okay.
In that PPT, it'll be defined in a much better way, much elaborate way.
Okay. Okay. That will be nice. Actually, that will be a lesson which they can take it, and they can uh, experiment with.
Yes.
Yes. Please, if you have any questions, please ask here now. I was told that there are some students who had some questions from the last session. Please type your questions, or if you want to unmute and talk, we can unmute you.
Hi Girish. Hello, hello.
Yeah, hi.
I don't have any question. So, but as Alok mentioned in the beginning, it's good to see good participation on the holiday itself. I can see 43 students till the end. So I think we already completed 3 sessions, and soon we have a offline event as well. So as we have decided, I hope students know like what is happening in compiler design, what all things are there. I know it's very early, but at least start thinking what you want to design, what you want to present in the offline event, because the overall aim of this series is to have a good offline event where you can showcase your learning, what you have learned, you have designed something, etc. Okay, so start thinking on that front, and as Alok will take over the other sessions, languages, etc., you can slowly start building on your idea so that you won't rush at the end of the session when we plan for the offline event. So that is just a comment for the student. Please start thinking on the ideas which you want to implement using this series.
Yeah,
Giri, look, you want to add anything, please?
yeah, what Sajal is saying, right? And you need some time to really think and plan your project. And this is a very good opportunity to learn. And yes, today we learned a lot of things which we may not have heard earlier. And you may feel overwhelming, but still, I think you should start coding whatever simple code, whatever Alok showed today. I think you should start with that. And once you start and looking at the output, I'm sure that you will start understanding in more detail. The thing is that you should start coding.
Also, when you start thinking about idea, it may happen, you may need a few other like as Alok mentioned today, like everything new for me also, because I'm not that from that background. You may need some other understanding knowledge from Alok. So maybe Alok can also add those aspects in the future session. So start thinking on those ideas.
Yes,
Yes.
of course, and do not hesitate to ask questions in the WhatsApp group also. Anytime, at least I can try to answer. Basically, start small. So like write what I have done so far. Write 3 lines of main.cpp,
Yeah.
where the main function is there. 15 lines of lex file, and 15 lines of yak file. Zipper file. And basically, even what is there, only 4 keywords is there, and one lexical scanner, just to scan the identifiers. That's all. So just start like that. You don't have to parse even the whole. but I'll show next time like how to create a test case, right? Regression is part of our this thing. So module name, then port list a comma b close bracket semicolon, then input a, output b, then end module. Bus. Just try to parse that thing. If you can do that, then you are a compiler designer. Now adding more is just an incremental effort. But creating that small test case, like an empty module with few keywords, if you can do it, you can create the whole language, whole compiler. Believe me. Anybody, any questions or any thoughts?
Yeah, there is somebody typed something. What is that? I mean, I saw like can you please be more? Can you explain what you're asking, Krishna?
Krishna, you can unmute and ask your question. No need to type. Girish sir,
Yeah.
can you take the questionnaire in the WhatsApp group?
Yes, we can do that. Yeah.
Yeah, and also one announcement. Actually, I missed few members in the WhatsApp group. Give me 1 or 2 days time. I'll make sure that everyone is added, as there are few last minute new registrations. And sorry for the trouble. Yep. Girish sir.
Yeah.
Anything is left?
Yeah, that's all. I don't think there is any questions. If they have, I think they will ask in the WhatsApp group or they'll send a mail. I think we can close this session now.
Yeah. Thank you, sir. Thank you, Girish sir. Thank you, Aloke sir, for the wonderful session. Guys, see you in after 2 weeks. Bye bye.
Yeah. Thanks.
Bye.